Hey everybody, in today's video we're talking about how to solve quadratics by factoring, okay? So I'm going to link some old factoring videos if you need to refresh in your memory on how to factor. And today we're actually going to be solving those quadratics. So yesterday we talked about how a quadratic, okay, is a nonlinear graph and the rate of change is not constant, meaning it's not the same. And that when we're solving for it, we're looking for our x-intercepts, we're looking for our roots, our solutions, and our zeros. So where they cross the x-axis at, okay? So now, when we solve, we want it to set equal to 0. So in this case, in number 1, it's already set equal to 0, so we're good to go. And then we're going to factor. So in this case, a is 1. So I'm going to look at my c value. I want factors of 3 that add up to 4. Okay, so that would be 1 and 3. And since a is 1, I can jump down to our shortcut and say x plus 1 and x plus 3. But now this still equals 0. So how do I solve for x? Well, because it equals 0, I can take both factors and set them equal to 0 since I know one of them has to equal 0 to get 0. So you set both expressions equal to 0, okay, set both parentheses equal to 0, and then you solve. So you do minus 1, x equals negative 1, minus 3, x equals negative 3. So you have two answers because it's a quadratic, it's a square. So just like our graph, we have 2 points here that cross the x-axis. So our answers are x equals negative 1 and x equals negative 3. Okay, number 2. Number 2 is not set equal to 0. So we need to set it equal to 0. So I'm going to add the 5 over x squared plus 3x minus 10 equals 0. And from there we're going to factor. So a is 1. So I'm going to do negative 10 and 3. And that would be negative 5. No, that would be positive 5 and 2 and negative 2. That would be negative 10. And that would give me positive 3. So x plus 5, x minus 2 equals 0. And then you set both of those expressions equal to 0. And you solve, so you have x equals negative 5, x equals 2. Okay, let's jump down to number 4. Oops. Sorry, I'm trying to erase. There we go, if we can see it. Okay, so we have 8x squared plus 8x equals 240. Now, what I want to do is I want to set it equal to 0. And I have 8x squared plus 8x minus 240 equals 0. So a is not 1, so we could do the AC method, but these are some crazy big numbers. So I'm going to look for a greatest common factor. In fact, 8 is a greatest common factor. So I'm going to divide the entire thing by 8, even the 0. And that way the 8 will go away because I'm doing it to both sides. Okay? If I only did it to the left side, I would have to include the 8. It would look like this. But what I'm really doing then is dividing this side by 8, dividing this side by 8. So I'm just saving a step by dividing everything by 8, and then the 8 goes away. Okay? So I now want to factor this. So a is 1, which is very helpful. So factors of negative 30 that add up to 1. That would be 6 and negative 5. 6 is a positive 6. Yep. So then we're going to do x squared minus, nope, sorry. We're going to do x plus 6, x minus 5 equals 0. You set each expression equal to 0. And then x is going to equal negative 6, and x is going to equal 5. Okay, so you might be asking, well, what's the difference between yesterday and today? Well, yesterday I gave you something that looked like this. X squared plus 5 equals 9. And today you're getting something that's like x squared plus 4x plus 5 equals 9. What's the difference? Today we have the linear term, this term right here, okay? So what we did yesterday would not work. We cannot apply the square root. This one we can take the square root because there's no linear term, okay? We have an x squared and an x, and so if I were to subtract that 5 over, I have x squared plus 4x equals 4, and then I subtract the 4x over, I have x squared equals 4 minus 4x, and then I take the square root of it. Well, I still have an x inside the square root. So whenever you have the linear term, meaning you just have an x, and it's linear because the exponent is 1, you have to factor it, or do other ways, but right now we factor it, okay? So yesterday we were able to just take the square root because we only had the x squared, and there wasn't the x in there.